Okay, let's unpack this. If you've been interacting with artificial intelligence lately, you've likely noticed a profound shift.
Yeah,
It's
definitely.
no longer just spitting out text answers to your questions, it's starting to actually act on your behalf.
That's the key word. Act.
Think about it. AI models are now drafting complex emails, scheduling meetings, analyzing massive data sets, maybe even booking travel for you.
It's a big leap.
Yeah, this isn't just better language generation. It feels like a leap towards AI that takes real action, in the digital world at least. So, how is this fundamental evolution actually happening?
It's a transformation that feels almost organic in a way.
Mm.
And to really get a handle on it, we're going to dive into a perspective that looks at this whole technological shift through a pretty different lens, genetics and biology.
Ah, right. This deep dive is inspired by the really fascinating work of Dr. Lee Minsa, particularly his insights in Genome Compass.
Exactly. He has this really unique approach.
Yes, Dr. Lee looks at these major tech advancements, AI, genomics, all that rapid progress, and he interprets them through the kind of complex interactions you see in biology.
Like how genes and epigenetics and the environment and experience all kind of weave together.
Right. He uses that biological framework to understand how society and tech are evolving, looking for parallels, that give us both scientific and maybe philosophical ways to think about our changing world.
Precisely. So
Yeah.
instead of it just seeing AI as like complex code or algorithm,
And that's just how most of us see it.
yeah, Dr. Lee encourages us to view it almost like it's a developing biological entity, something with its own structure, its own regulatory systems.
Okay.
And central to this shift towards AI that acts, which the source calls actionable intelligence, is a concept Dr. Lee highlights,
Mhm.
MCP, Model Context Protocol.
MCP. Okay, so our mission today is to really get inside this idea of MCP. How does it let AI move from being essentially a very smart encyclopedia and text writer to something that behaves in a much more dynamic, responsive, and yeah, maybe even biological way? We're going to try and connect the dots between how AI works operationally and something as fundamental as like our own genetic controls.
Okay, let's set the stage a bit, like the source does. Think about where AI came from.
Mm.
Not that long ago, using a large language model was mostly, question and answer.
Right. You ask, it
You
answers.
type in a query, and the model, using its huge training data, generates some relevant text. It was amazing at processing and generating language,
Mm.
but its connection to anything outside its own data was, well, pretty limited.
Yeah, like having this incredibly knowledgeable librarian who could write beautiful summaries but couldn't actually, go pull a book off the shelf or make a phone call for you.
That's a perfect analogy. That was
Yeah.
the starting point.
Yeah.
But now what users expect has changed dramatically.
Oh, for sure.
You don't just want the AI to tell you about booking a meeting. You want it to actually schedule the meeting.
Yeah, put it on my calendar.
Exactly. Or you don't just want it to summarize data. You want it to analyze it, maybe even create a report from it. This demand for AI to do tasks that interact with external systems could be your calendar app, email, a database, a web service that defines this evolution into actionable intelligence.
And that feels like a huge leap, technically speaking, because those older models were mostly designed for internal math and text output, right?
Yeah.
Not for reaching out and messing with things in the digital world.
hmm
So for AI to do these new tasks, it needs to figure out, like, dynamically which specific tool or capability it needs right now based on what I asked in the situation.
That sounds tricky, coordination-wise.
It is. It's a critical challenge. And according to Dr. Lee's perspective in Genome Compass, this is exactly where the Model Context Protocol, MCP, comes in. It plays this absolutely pivotal role.
Okay, so MCP.
Think of MCP simply as the connection protocol that gives the AI the essential ability to select and use tools.
And tools here means things like APIs, plugins, specific functions,
Mhm.
maybe even other AI models. Precisely. All of the above. But MCP isn't just like a static list of tools. The source describes it more as a sophisticated meta recognition and execution system.
Meta recognition.
Okay.
Okay.
Yeah. So the AI, with MCP working, becomes aware of the whole suite of functions it could potentially call on its entire repertoire. Then, based on the specific context of your request, the surrounding environment MCP lets the AI automatically figure out which specific tool or function is the right one for the job right now, and then it executes it.
Okay, walk us through that weather example from the source. That might make it clearer.
Sure thing. So imagine you type, "What's the weather like in Seoul tomorrow?"
Okay.
An older model might just generate text about Seoul's typical weather, maybe pull some facts from its training data, descriptive stuff.
Right. Stuff it already knows.
Exactly.
Mm.
But with MCP, the AI parses that request and sees more than just words. It recognizes a need for specific current data, tied to a location, soul, and a time, tomorrow.
It understands the intent is for real-time info.
Precisely.
Hmm.
And it knows that among its available tools, there's likely a weather API. MCP allows the AI system to recognize this need, select that specific weather API, actually initiate a call to it, retrieve the live forecast data for Seoul tomorrow, and then critically process that data back into a normal user-friendly answer.
Wow. Okay, so that's a whole sequence. Understand the need, find the right external thing, connect to it, get the data, and then make sense of it for me. That's way beyond just matching text patterns.
Way beyond. It involves this internal orchestration, you could say,
Okay.
searching its own capabilities, connecting to the right one, running it, integrating the result. And importantly, Dr. Lee's work really emphasizes that MCP isn't just some technical plumbing.
Right.
He views it much more deeply. He talks about it functioning like a kind of genomic network inside the AI,
Hmm.
fundamentally allowing it to interact functionally, dynamically with its external environment.
A genomic network. Okay, now we're really getting into Dr. Lee's core idea, the genome compass perspective, this biological analogy.
Absolutely.
Yeah.
This is where the source draws that direct and I think really compelling parallel between this AI setup model, potential functions, a system to activate them, and how biological organisms work with their genetic code.
Right.
Think about us, humans. We've got, what, around 20,000 genes in our DNA?
Something like that, yeah.
That's the whole blueprint.
Yeah.
All the instructions for everything our body could potentially be or do.
Yeah.
But are all 20,000 genes switched on all the time in every single cell?
No, definitely not. That would be chaos. It's why a muscle cell is totally different from a brain cell, even though they have the same basic DNA instructions.
Exactly. The difference is which specific genes are on or off in that cell type at that moment in that environment.
Mm-hmm.
This selective activation gene expression, it's incredibly complex, tightly regulated. It's controlled by these intricate systems, transcription factors, epigenetic regulators, other things that sense what the cell needs, what the environment is like, and then activate just the necessary genes. And this regulation, it's not just a detail. It's fundamental to the complexity, the adaptability, the sheer diversity of life.
Okay, I'm following this biological picture. So, if we map that onto AI, according to the source, the huge AI model itself, the one that could potentially use countless functions, tools, APIs, that's like the digital version of the genome. It holds all the potential instructions, all the digital genes.
You've absolutely nailed the core analogy Dr. Lee presents. And in this view, MCP acts like the sophisticated transcription regulation system, or maybe a functional expression coordinator for this digital genome. Just like those biological regulators read signals from the cell's environment and switch on only the needed genes. MCP looks at your request, the surrounding digital context, the AI's environment,
Right.
and decides which specific functions, which digital genes need to be connected and expressed or activated right now to get the job done.
So it's almost like MCP is the intelligent conductor for the AI's orchestra of potential. The model has all the instruments, the genome, but MCP reads the score, the context, and tells specific sections when to play.
It's a really good way to put it. The source argues pretty convincingly that without this regulatory layer, the AI is just, well, a massive library of potential, a static blueprint.
Right. Impressive, but inert.
Exactly.
Okay.
But with MCP, it transforms into what Dr. Lee calls a contextually active intelligence system. It shifts from being passive information to an active agent, something that perceives its situation and then behaves or reacts dynamically. A bit like how a living cell responds to its environment by turning on the right genes to survive or function.
And this biological link gets even deeper when we think about the future Dr. Lee seems to envision for AI. Because in biology, complexity and evolution don't just come from having more genes, right? It's about the incredible subtlety of regulating when and where those genes get used.
Precisely. That regulatory machinery is the engine of diversity in biology. It's the key to adaptation, the driver of evolution. It's all about selective, context-aware expression of potential.
So if we extend that thinking to AI development, maybe the path to truly smarter AI isn't just about making the models bigger and bigger, adding trillions more parameters. Maybe it's fundamentally about getting better at this. This ability to sense the situation, pick the right capability from its huge potential at the right moment, and use it effectively.
That contextual expression of intelligence.
Exactly. That could let AI act more like how humans solve problems or even, evolve towards more integrated, adaptable kinds of intelligence.
And Dr. Lee's work positions MCP as the core mechanism driving that potential evolution. It provides the necessary pathway for the expression of intelligence for these big models like GPT.
The pathway.
Yeah. It lets AI not just crunch data, but actively use external tools, interact in real time, operate less like a static program, and more like Barch. Well, the source uses terms like a digital living system or even a digital organism.
Digital organism. That's a provocative phrase. Makes you think differently about AI, not just as a tool we wield.
It really does. And it's the logical endpoint of the analogy being presented, isn't it? So
Continue.
a single cell uses parts of its genome selectively to do complex things to survive. AI, through MCP, regulates its own functions to interact, adapt, and live in its digital world. The source paints this picture of future AI systems not just as fancy calculators, but as digital genomes, maybe systems that could eventually design their own functions, regulate their own operations based on what they perceive, and potentially even continuously evolve or improve themselves.
Wow.
And in that future vision, MCP is seen as absolutely fundamental, like a core metagene that governs how all the other potential digital abilities get accessed and used.
Okay, that really reframes things. So let's try and bring it all together. The central idea we're taking from Dr. Liam-Mansub's perspective in Genome Compass is that MCP, it's way more than just technical wiring for tools.
Much more.
It's the core connection, the regulatory system, that lets AI models holding this vast digital potential like a genome selectively turn on specific functions based on the context, the situation they're in. And it's this mechanism, the selective contextual expression, that's key to AI evolving from just processing information to something behaving more like a living digital organism.
That sums it up perfectly. MCP enables that leap from understanding to acting, from static knowledge to dynamic, functional engagement with the world. It's the vital regulatory layer for AI's digital potential, allowing for nuanced interaction and setting the stage for potentially much more complex digital entities down the line.
So when we look at AI progress through Dr. Lehman-Zev's really fascinating biological lens, MCP isn't just about enabling plugins or APIs. It's fundamentally changing how AI operates, giving it a mechanism for contextual intelligence, for functional expression that honestly mirrors the complexity and adaptability we see in life itself.
It pushes us to look beyond just the raw size of AI models and to focus more on the sophistication of how they interact, how they regulate themselves. That might be where the true breakthroughs in intelligence lie.
And it leaves you with a pretty big thought, doesn't it? If AI really is developing something like a digital genome and NCP is acting as its core expression regulator, similar to the systems in biology, what does that really mean for its potential? Its potential to adapt, to evolve, maybe interact with our world in ways we can barely even imagine right now. It really makes you pause and wonder what new forms of digital life, if you want to call it that, might emerge from this kind of mechanism in the years to come.